Hi, and welcome to this demonstration of the Oakgate storage validation framework. Let's get things going by firing up the controller application. Okay, so what we see here is the typical user interface layout that we're going to be seeing throughout this demo. Down the left-hand side here are a number of icons which start up additional functionality, which we'll look at as the demo progresses. When we first come into the application, you can see that there are three tabs up already: Discovered Systems, Configure Systems, and I/O Exerciser. In the Discovered Systems tab, here we see a list of the test appliances that have been discovered that are on my local area network. And we just have the one, which is the MyCE test appliance, and you can see it's actually on the network at the address of 192.168.0.14, and it's currently stopped. So let's start it. So we're starting up the application, and now it's started. If we come over here to the Active Systems panel, we can now expand the entry for the MyCE test unit, and you can see that we have knowledge of 8 ports which can be used for testing drives. Now, if these are actually SAS and SAS and SATA ports. If we had an PCIe drive attached, we would see that in this area as well. So there are actually 8 ports here, although we've only got 4 physical ports in our 4-bay plug-in module. That's because 2 ports are connected to each physical port. So, for instance, port 0300 and 0304 are wired into the same physical ports that we can do dual port I/O operations if we wish to. So, but before we start our test drive, I'm just going to come over here and start up the peripheral control functionality, because I want to associate a power controller which we're going to use to monitor the power consumption of our test drive during the demo. So you come into the peripheral controllers functionality, and we ask to connect to a peripheral controller. When we do this, it asks us which system we want to connect the controller to, the MyCE system. Then it asks us the controller type. You can see here there's quite a long list of controller types, many of which are third-party devices. I actually want to start the mezzanine controller, which is the controller which is integrated with the 4-bay plug-in module. I'm going to connect by TCP/IP, and I know that the address of the system I wish to connect to is 192.168.0.14. So I connect, and it connects successfully to the mezzanine controller. So now I can come across and start my test drive. I happen to know it's in port 0301. And I come across to the Configure System tab, and here are the parameters that I can set when starting the drive. Most of them can be left the default values seen here. The topology is either SATA or SAS. I know it's an SATA drive, so I'm going to leave it as SATA. I now want to associate this drive with a specific port of our power controller. So I add a peripheral module and click port 1 of the mezzanine controller, and now I can initialize the drive. So it's now been initialized and discovered nicely. So I can come over to the Active Systems panel, and I can expand the entries for our drive. And for example, if I come down to the LUN level, I can see on the panel here I'm now seeing some information about the drive. Its product ID is Toshiba. THNSN81Q60SE, another great product name from Toshiba there, and its product revision or firmware level is 8EET6101. If I click the LUN features part of this panel, I can now see a list of the SATA features supported by the drive, including the maximum Q depth here at the bottom of 32, which is no surprise because 32 is the maximum for a SATA drive. Okay, so we've got our drive up and running. If we go over to peripheral control, highlight the port number 1, I can now turn power measurement on by measuring power, and if I auto refresh this screen, you can see the current power supply and power consumption values. Not much going on at the moment because there is no traffic running to the drive, so it's idling away. You can see the power is being consumed at this, on the 5-volt rail, which is typical for a SATA drive. Okay, so now let's start up the automation functionality. And here we can see in this central panel here a listing of the current test script. In fact, it's blank at the moment. Now we can either load an existing test script in here, one we created previously, or we can go ahead and create a new test by adding test sets and then adding actions in sets. Let's load a demo test which I created before. So I load setup file, demo test, open it, and you can see that it's loaded a little fairly straightforward test that I'm going to use this demonstration. Let's just expand the entries in the test script. And just to talk you through here, the first set is being used to precondition the drive prior to running a test which is going to do 4K random writes, but it will apply an IOPS cap to each iteration of the test. I'll look at this in more detail in a minute. In the preconditioning set, you can see there's a SATA secure arrays action which will clean the drive to an factory fresh out of the box state. There's then a disk prefill action which we're going to use to write sequentially to the drive. And if you look at the setup page of this action, the disk prefill percentage down here on the right is set to 200%. So it will write to 200% of the drive's user capacity, which will ensure that every LBA on the drive has been written to at least once. And then the following test action is to perform 4K random writes to the drive. And the duration of this test action is 6 hours, which is quite a long time, but it's a fairly big drive, a 1.6 terabyte drive, and I know from experience that it's 6 hours is about the time it takes to force the drive into a steady state where the performance of 4K random writes isn't really varying over time. Well, not much anyway. So if we look at the next set, we can see that it's got a loop in it which is going to iterate or repeat for every value of an IOPS cap that we've defined. So look at the setup page for this loop, and we can see down here on the right that it's set to iterate on IOP capping. I can choose other things to loop on, such as rounds, which is just to tell the test to run a fixed number of times, or to iterate on the Q depth, where we might want to vary Q depth or IO size and the like. Let's edit the values that we have here, and you can see at the moment it's going to repeat this loop for an IOP cap of 1,000 through 40,000 in increments of 1,000. so it'll run the test 40 times. Let's just clear those values and change them to an initial value of 5,000 IOPS, an end value of 40,000 IOPS, and an increment of 5,000 IOPS. And usefully, SVF will now generate the required entries, so 5,000 through 40,000, increasing in 5,000 steps, in steps of 5,000. I'll just save that. Okay, so this is a pretty straightforward test, and you can see it's very easy to create tests in SVF. You don't need to do any coding. I mean, for instance, let's just add another test set. So we go to the test line, right click on it, and say add test set. And you can see at the bottom it's added another test set. Let's go to its setup page, and we'll change the name of this to increasing IOPS cap 4K random reads. And then I can add a loop, add item test loop to this new set, and it's got a default of iteration on Q depth at the moment. I'll change that to also iterate on an IOPS cap. I'll edit the values it's iterating on, and give it again an initial value of 5,000, an end value of 90,000, and increase in 5,000 in steps of 5,000. So generate the entries and save them. Okay, now I'm going to add a test line inside the loop. So I add test. I could add actions such as secure arrays or disk prefill, etc. I'm going to add a test action. I'm going to go to the setup page again, call this, give it a name, this action of 4K random reads. Excuse my typing. And then I'm going to define the traffic that I wish to be carried out, the I/O traffic that I wish to be carried out in this test action, which is going to repeat itself for each of the IOPS caps that we've defined. So I go to the LUN path line and then go into the I/O traffic tab, and here you can see the parameters that we can vary to control the traffic. If you've used Iometer, many of these parameters will be things you've seen before, familiar to you. So for instance, we have Q depth here. I'd like to set this to 32, the maximum Q depth. We've got an I/O cap being enforced by the loop. Traffic patterns, well, I want it to be 100% random. I'm reading here, and the read size is going to be 4K. So I'll put that in here. I want 100% reads. I don't need to worry about I/O alignment because we're reading, or data pattern because we're reading. By the way, the data pattern in all of the previous I/O traffic settings is all fully random. Okay, so that's all right. So now we're ready, we're almost ready to start this test. Before we do, we've got to associate this LUN path 0 with the test drive that we want to be used in this test. Now we can actually run this test against multiple drives at the same time by adding more LUN paths and associating each of those LUN paths with a different drive. We're only going to be testing one drive in this demo. So we can go across to the I/O exerciser, and the I/O exerciser has an entry in it at the bottom here, which we can copy by right-clicking it, copying all LUN settings. Then we can come back to the Test Automation tab, cut across to LUN Association, select LUN path 0 and paste the LUN path details that we've just taken across from the I/O exerciser and associate LUN path 0 with our Toshiba THNSN81Q60 drive. So now we're ready to start our test. I hope you can see it was pretty easy to add that third set there. So here we go, press the start button. Now it's telling us here that, or asking us if we'd like to remove the previous test results associated with this script. I do want to remove it, so I click remove. I could, if I wished, have gone across and moved those results somewhere else or rename them prior to starting the test. So as our preconditioning step started, it turned blue. The secure erase is now finished, so it's turned green, and it tells us it was successful in that it passed. And now we're on to the disk prefill step. Now this is going to run for an hour or so, and then the 4K random writes step is going to run for 6 hours. So before we pause the demo for a number of hours, let's have a quick look at some of the things we can look at whilst things are running. So first of all, let's come across to the I/O exerciser and click its I/O traffic panel. And you can see here the nature of the actual traffic that's running right now. You can see it's running at a queue depth of 32. It's 100% sequential. If we come down a bit further, we can see that the write size is 128K. We're doing 100% writes. The writes have been aligned to 4K boundaries, which is good. And the data pattern that we're currently writing is 100% entropy, which is 100% random. Okay, so now we can come across to the left-hand side of the screen and press the dashboard icon. And up comes this display, which shows some nice graphs of the current IOPS and bandwidth performance and the cumulative IOs since we last started, which have accumulated since we last started the dashboard and the cumulative bandwidth. Okay. Let's now go back to the peripheral control panel, and we can see the current power consumption. And we can see here that in terms of power consumption, that all the action is on the 5-volt rail. There's nothing really happening on the 12-volt rail or the 3-volt rail. Okay, so as I said, we're going to need to wait several hours for this test to complete. So I'll pause the demo at this stage and come back later to see how things are going. Hello and welcome back to this demonstration of the Oakgate Storage Validation Framework controller application. So you can see in the center column here that all of the steps within our test sets of our demo test script have now completed. So let's go ahead and look at the ways in which we can look at the results of the tests and indeed report upon the results of the tests. So to do that, we go across to the Performance Graphing tab, and you can see that I'm actually in the set 2 where we're increasing the I/O cap for 4K random writes. And if you look down in this graph box towards the bottom here, you can see I've previously created 3 graphs, one to report upon the average IOPS achieved in each iteration of the test, and one to report on average latency, and the next to report on maximum latency. So just to show you how easy it is, I'm going to create another graph for this set. Add a new graph, I'll give it a new name, and let's call it average power consumption. enter, and I come over here to the axis values, and I'm going to change my y-axis to plot the total power. And if I press regraph, up comes a graph. SVF generates a graph which shows the average total power consumption for each of the iterations of the test. Again, I can set the click value here to 5 volt plus 12 volt total power. So if I come up and click one of the points on the graph, oh, it hasn't come up yet. Let's look at it. Here we have a detailed picture of the power consumption over time, which has gone to make up that average value. Okay, so I think you'll agree it's pretty easy to add graphs here. You can also notice in this graph box that we can tick a box to include the graph that we've defined to be included in a report. So I'll just check that the pre-con 4K writes is included. It is. Then I'm going to go up to the demo test line, right click and select create test report. And the first thing I need to do is decide where I'm going to put it. I'm going to put it in this MISC folder, and I'll call it demo report 3. Press save. Now here we have the option to include low-level details in our report. This is the detailed information behind the higher-level graphs that we looked at a while ago in the SVF. We can also include low-level power details, which I'd like to do. We can also combine LUN path results, so that we combine the results for more than one drive, or more than one port, into one graph. This is useful, for instance, if we're doing dual port testing, where we can combine, the performance of both ports together. So now I'm going to, we're testing one drive, so I'm going to create the new report. It's going to take a minute or two to do. It creates two types of reports, one an HTML report and another PDF. We'll have a look more closely at the HTML report in a moment. Oh, just on the left-hand side in Active Systems, you may have noticed that our entry for the Toshiba drive has turned into a sort of reddy brown colour, which signifies that it's failed. This is because, ironically, the UPS man came to collect the drive to return it to Toshiba before I started the recording of this second part of the demo, so the drive is no longer in. Okay, so anyway, looking back in the middle here, it's now creating the HTML details. Won't take long, so we'll just wait for it. Nearly finished. Oh, now creating the PDF files, and it's taken us in and given us an opportunity to look at the results of or the report. Rather than going in this way, what I'm going to do is show you how to access it through the files it's created. Look in our MISC folder, here we see demo report 3, and you can see all of the entries that it has created. There's actually a lot of detailed entries as well for each of the graphs, HTML files, XML documents, and pictures. So anyway, we go back to the high level, and if we select pindex0, the HTML file, this is the root of the HTML report, so we'll open it, and you can see at the high level we've got a picture of all the graphs that we asked to be included in our report. So for preconditioning, for the increasing IO cap for 4K random writes, we have IOPS latency, max latency, and power consumption. So if we go up to this average latency report, we can have a look at the graph details that have been recorded behind it. So we press graph details, and here you can see the details that it's recorded. So first of all, the absolute value, the average values that have been used to plot the high-level report. And here, the detailed values that have been recorded for each of those plots on the higher level graph. So for instance, if we go across to the 30,000 IOPS cap row, we can click this graph schematic in the right IOPS column, and this brings up a detailed picture of the performance over time graph that has constituted the average value at the higher level. I can also, by clicking the right IOPS letters, pressing open, new downloads, get this right in a minute. I can see the actual values that have been used to plot the detailed performance over time graph. And I can, of course, take those into Excel. Actually, I'm looking at them in Excel, so I can produce my own graphs of those details if I wish to. Okay, so you can see a lot of detail has been recorded. I can look at latency distribution graphs as well. So again, for the 30,000 level, I click this schematic in the high res right latency column. Here's a high res latency distribution graph, where you can see the distribution of the latencies or the counts of things. You can see that 99.999% of the time a latency of 22.76 milliseconds was achieved. At a 95% level, a latency of 670 microseconds was achieved. Okay, so you can see a lot of detail is recorded, which is a great benefit to me as a reviewer, because it gives me an easy way of filing not just the results of my tests, but the detailed data behind them, which is really, really good. So just a quick look at this preconditioning step. If I look at the graph details and look at the right IOPS schematic, here you can see a picture of the performance over time of the 4K random writes preconditioning step, and you can see the same picture that we saw inside SVF, where you can see the performance over time over the 6-hour period. So at the beginning, it's when we've got fresh blocks to write to, then we go over the right cliff, and then it eventually settles in to a reasonably consistent performance over time. Okay, so that's it. That's what that's the end of the demo. I hope you can see how easy it is to create things and report upon things in SVF. I should emphasize I've focused on the sort of functionality I use for performance benchmarking, but SVF has the ability to do a great deal more, such as injecting errors into your traffic, so you can test how the drive behaves in error conditions. We can validate the data that has been written is still there. We can do directed reports where a user can specify their own result tests to be performed using various APIs, so they can do anything they wish using the SVF framework. But anyway, I hope this gives you a reasonable feel from what is, I'm not sure if you agree, but it's a fairly brief demo of the functionality that SVF has. Okay, so thank you for your concentration, attendance, and patience. Cheers.